So, polynomial division. This is one of Schlegel's least favorite topics. That being said, we're going to go ahead and get right to it. Dividing polynomials the long way is just like doing regular long division with a bit of a twist, and we'll get to that as we go through this. And so, we've got 3x squared is what we're dividing into 18x to the sixth minus 24x to the fifth. And so to start off, what we need to do is see how many times 3 goes into 18. And so 3 goes into 18 6 times. And how many times does x squared go into x to the sixth? We would need 4 more x's, and so x to the fourth. And so then just like regular long division, we multiply 6x to the fourth times 3x to the power of 2. And we get 18x to the power of 6. And remember, with long division, we're going to be subtracting this, right? So 18x to the 6th minus 18x to the 6th leaves nothing. Our 24x to the 5th comes down. Remember, it's negative. And so now we think, how many times does 3 go into 24? Well, 3 goes into 24 8 times, and it's going to be a negative 8 because we need a negative 8 times 3 to make negative 24. And then x to the power of 2 to become x to the power of 5, we need 3 more x's. So now we're going to multiply negative 8 times negative 3, or negative 8 times 3, we get negative 24. X to the power of 3 and x to the power of 2 makes x to the power of 5. And remember, we're subtracting here. So negative minus a negative is going to be moving in the opposite direction. Basically, the idea here is that's going to make 0. And so we don't have any remainder. I'll go ahead and pause here for a moment and let you do that if you need to. And so next we have 2z to the power of 3 being divided into 14z to the power of 7 minus 18z to the power of 5. And so just like last time, how many times does 2 go into 14? Well, 7. And to get from 3x's to 7x's, we need 4 more. So we multiply 7 times 2 is 14. Z to the power of 4th and z to the power of 3 is z to the power of 7. We subtract. We get nothing because they are equivalent. And so it comes down our 18z to the power of 5. And so, again, it's negative, so our number up here is going to have to be negative. 2 times 9 makes 18. And to get from 3z's to 5z's, we need 2 more. And so negative 9 times 2, again, we're subtracting. Negative 18z to the 5th. That comes out even, so we have no remainder. I'll go ahead and pause here for you, and then I'm on to the next page. So this is where it starts to get a little bit nastier. What we've got is we have 2 things that are going to be outside the division box, and so that's kind of wacky. We're only going to pay attention to the leading coefficient, though. And so in this case, we're only going to pay attention to this 1 that's out here in front of the x. And so how many times does 1 go into 5? Well, 5 times. And how many more x's do I need to get from x to the power of 2? I need 1 more. So now we take our 5x and we multiply it by all of this stuff out here. And so what we're going to have is 5x times 1x makes 5x squared, or 5x to the power of 2. 5x times 7 makes 35x. And we need to remember, we are subtracting. So 5x squared minus 5x squared is going to make nothing. 40 minus 35x is going to make 5x. That's going to drop down, plus 37. So now we need to think about how many times does 1x go into 5x? Well, 5 times. And we take our 5 and multiply it by x plus 7 to get it down here to the bottom. So we are going to be subtracting. We need to remember 5 times x is 5x. 5 times 7 is 35. So we subtract those. 5 minus 5 makes nothing. 37 minus 35 makes 2. So we are going to have a remainder of 2. Alrighty. Again, this topic is not my favorite. I sort of wish we could just skip over it. You're probably never going to use it again after today or on the test. So anyway, moving on with life. We've got a 6x minus 1 divided into 18x to the power of 3 plus 33x to the power of 2 plus 18x plus 2. And so again, we just pay attention to the leading coefficient on the outside. So 6 goes into 18 3 times. To get from x to the power of 3, I need 2 more. So x to the power of 2. Then I multiply by 3x to the power of 2 times 6x minus 1. I get 18x to the power of 3 minus 3x to the power of 2. Now again, it's important to remember we're subtracting here. So 18 minus 18 is going to make nothing. 33 minus a negative 3, that's going to change to addition and make 36x to the power of 2. My plus 18x comes down. Alrighty, so 6 goes into 36 6 times. And to go from x to the power of 2, I need 1 more x. So again, we're subtracting. We're going to do 6x times 6x is 36x to the power of 2. And 6x times negative 1 is negative 6x. So again, we need to remember that we are subtracting, and so the 36's are going to make nothing. 18 minus negative 6 is going to be 18 plus 6, which is 24x. Again, because the two negatives make a positive, so 18 minus negative 6 is the same as 18 plus 6. So we get 24x. And our 2 is going to fall down. Okay. And so now we need to think about how many times does 6 go into 24. It goes in there 4 times. And we have 6x. If we multiply by 4, that's going to give us 24x, and so we don't need any x's. So again, we're subtracting. 4 times 6x is 24x, and 4 times negative 1 is negative 4. So we have 2 minus negative 4, which is the same as 2 plus 4, which is going to be 6. So our remainder here is going to be a remainder of 6. Okay, I'll pause so that you can if you need to, and I'm on to the last problem. This last problem is particularly nasty, and if you don't totally understand it by the time I'm done, that's okay. Really, 1 through 4 is the only kind of problem that is going to show up on the test or anything like that, and probably on Alex as well. But what we've got that makes this unique, one moment. So the piece that makes this wacky is that 5x to the power of 2 minus 2. And I'll show you why it makes it wacky, because what I need to do is I can't skip over a type of term. So like I have a 5x to the power of 2, but there's no x's there. And so I need to write that I have 0 x's and then minus 2, just for the division to work out correctly. And so we'll have 20x to the power of 3 plus 17x to the power of 2 plus 5x plus 3. And so I need that 0x there, because what would happen if I didn't have it was I would not have a term to put here under the 17x squared when I do my multiplication, and you'll see that in just a minute. So 5x to the power of 2 goes into 20x to the power of 3 4 times. And to go from x to the power of 2 to x to the power of 3, I need 1 more x. And so now 4x times 5x to the power of 2 is 20x to the power of 3. 4x times 0x makes 0x squareds. And 4 times negative 2 makes negative 8x. So again, remember that we are subtracting. So the 20s will cancel themselves out. 17 minus 0 is 17. And 5 minus a negative 8 is the same as 5 plus 8, so that's going to be 13x. And then, as with the other division problems, our other term there is going to fall down, so we get a plus 3. So now, we look how many times does 5x to the power of 2 go into 17x to the power of 2. That would be 3 times. And 3 times 5 is 15. X to the power of 2. There are 0 x's. 3 times 0 is 0, and then 3 times negative 2 makes negative 6. Important to remember that we are subtracting. So 17 minus 15 is 2x to the power of 2. 13x plus 0 is going to be 13x. And 3 minus negative 6 is going to be the same as 3 plus 6, which is 9. So our remainder here is a particularly nasty one, 2x to the power of 2 plus 13x plus 9. Oh boy. Schlegel is glad that lesson is over. I hope this is helpful. Hope you have an awesome day.